Hi, ladies and gentlemen. I welcome you to our YouTube channel. My name is Professor Kevin. So please, before you can continue watching this video, please make sure that you like the video and also subscribe to our channel. You can also share this video with your friends. So in this video, we'll be looking at the integral of x over the square root of y minus x to the exponent 4. So to integrate this function, we need to use substitution, but you should be very careful when using substitution in this function, okay? Because now we are not going to take the whole inside function and let it to be u, because if you do that, it's gonna be more complicated. You might end up integrating the whole day non-stop. So to make things easy, we have to pick a factor that if we integrate, it can eliminate the numerator, okay, or the outside function, which is x. So from x to the power of 4, if we pick x squared and make it to be our u, when we differentiate x squared, we can get 2x, which can easily eliminate that x, okay? So before that, we need to write this thing like this: integral of x over the square root of 1 minus x squared all to the exponent of 2 dx. Okay, so right now we can say let u be x squared. So when you differentiate du over the x, we're gonna get 2x. So the x here is going to be du over 2x. So now let us continue and substitute everything. We're going to have integral of x divided by square root of 1 minus u squared. And then the x we said is du over 2x. So you can clearly see that x and x are going to divide each other. So now we're going to have 1 over 2, then integral of du over the square root of 1 minus u squared. So now we can clearly see that to integrate from here, we need to use the trigonometric substitution. I hope you remember the trigonometric substitution. If you have square root of a squared minus b squared x squared. So now in this case, you are going to set your x to be a over b times sine of theta. So right now, because we don't have x, so we're going to talk about u. We will set our u. We set u to be, if you can check a and b in this function, it's 1. So it's like 1 over 1, which is the same as 1 times sine of theta. So now let us go ahead and determine du. Du is going to be cos theta d theta. Because when we differentiate here, we're going to get du over d theta, which is going to be cos theta. So if you make du to be the subject of the equation, that is what we are going to have there. So right now, let us come back and substitute everything. We're going to have 1 over 2 integral of, remember du, we said it's cos theta d theta. All these things divided by square root of 1 minus sine square theta. So right now, we are going to have 1 over 2, then integral of cos theta divided by the square root of cos squared theta or d theta. So when you solve this thing, you can clearly see that now you are going to have, because square root of cos squared theta is the same as cos theta, so it's like we have integral of cos theta over cos theta, which is 1 d theta. So in this case, we're gonna have 1 over 2, and then if we integrate 1 with respect of theta, we're gonna get theta plus c. So now we need to go back and check what is our theta. So to find our theta, we're gonna use this one where we set our u to be sine theta. Remember, u is sine theta. Sine theta is equal to u. So if you want to solve theta, it means theta is going to be the second function of sine into u, or arc sine u. So now we're gonna have 1 over 2 to the inverse of sine u plus c. But from the beginning, what was our u? Our u, we said it's x squared, so it means that this thing is gonna be 1 over 2 into the inverse of sine x squared plus c. So we are done integrating this problem. So I believe you enjoyed this video. Please do not forget to subscribe to our channel and also like this video and share it with your friends or fellow learners.